the most crucial components of the atmosphere. And how do we use this crucial component to understand other atmospheres and connect it with our own? Hello and welcome. I am El-Sharkawy, and this is my talk on Rossby waves and Rossby waves and planetary atmospheric studies and comparisons. So, Rossby waves. First, what do they look like? Like this. So these are the waves right over here, and the dark red part is where they're fastest, and the light blue part over here, for example, is where they're slowest. So here's the crest, and here's the trough. So what exactly are we looking at? Rossby waves are waves that occur in rotating fluids, and they occur due to the Earth's geography and its rotation. And it's rotating fluids. So fluid can be a liquid or a gas. So it happens in the atmosphere and in the ocean. And they're influential in both, however, we'll only be looking mainly at the atmosphere. And this is from the NASA Goddard Space Flight Center, which they posted this in March of 2017. So according to the NOAA, which is the National Oceanic and Atmospheric Administration, Rossby waves transfer heat from the tropics, where it's hotter, to the poles, where it's colder. And they transfer cold air from the poles, where it's colder, to the tropics, where it's hotter. And it does this to balance out the temperature gradient, aka the difference in temperature between the tropics and the poles. So as shown over here, this is actually from the DW, not from the NOAA, but it still shows the concept. Hot air is being moved to the north, and cold air is being moved to the south. And this is what a crest is, and this is the trough. So the crest is the top of the wave. And this is really important because crests form high pressure systems and troughs form low pressure systems. A high pressure system is basically good weather, and a low pressure system is bad weather. So rain, storms, that's what a low pressure system causes. And we can actually predict the weather using Rossby waves. Okay, so how does it connect to planetary atmospheres at all? According to Zakharashvili, along with numerous other authors who published a paper in the Space Science Reviews in 2021 titled Rossby Waves in Astrophysics, Rossby waves are very important in other rotating bodies like Jupiter, Mars, Pluto, and even the Sun and other stars. So as we can see here, this is a picture of Jupiter on the left, and you can clearly see the Rossby waves in the jet streams over here. And this is actually the Sun. So what this is trying to show is the number, or the wave numbers, which is what the variable n is. So the Sun has three main wave numbers, or Rossby waves of three main wave numbers. Wave numbers of 3, 7, and 11. And the red here shows the wave is rotating clockwise, and here it shows, the blue shows that it's rotating counterclockwise. Alright, so why should we care? Why should someone who is not an atmospheric scientist or aspiring atmospheric scientist like myself, or even one who is an atmospheric scientist but isn't looking at other planets, why should they care about any of this? How is it going to help them? Well, according to Mehdi Yusuf in her talk with Laurel Ruma in the MIT Technology Review just 3 months ago, actually in April of 2022, she was explaining how studying the Martian atmosphere and the evolution of the Martian atmosphere can help us understand how our planet might evolve. For example, with carbon dioxide increasing in the atmosphere. So to recap, Rossby waves are crucial components of our atmosphere. That's number one. Number two, they can further our understanding of other atmospheres. And number three, by extension, we can further our own understanding. Our own understanding of our own atmosphere. And I'd like to conclude with a quote by Bevon M. French, where he says in chapter 2 of the book, Messages with the Universe, Earth is probably the worst place to learn the laws that govern Earth's weather. We have to examine other worlds with simpler weather patterns in order to learn about our own. And this is my work cited. And that concludes my presentation. Thank you very much.